polynomials. Question 1. The zeros of pz equals z cubed plus z squared plus 4z plus 4 are. Right, so we've got to let this equal to 0. So we'll have to find them. So we get z cubed plus z squared plus 4z plus 4 equals 0. Now, before we find a 0 by substitution, first we'll have a little look, and we can actually factorize this. And we'll split that down the middle. We get z squared outside of z plus 1 plus 4 outside of z plus 1 equals 0. So it's always important just to have a little look, see if you can do that. Can't do it all the time, but it's very useful if you can. That becomes z plus 1 outside of z squared plus 4 equals 0. Therefore, z plus 1 equals 0, or z squared plus 4 equals 0. Now clearly here, z must equal -1. Here, z squared equals minus 4. So z equals plus or minus the square root of minus 4, which is plus or minus 2i, is the other zeros. Done. Number 2, given that z equals 1 plus 2i is a 0 of pz equals z cubed minus 4z squared plus 9z minus 10, find all the other roots of pz. Now, because all these coefficients are rational or real, we can then say that there will be another root, which will be the conjugate of this one. So we've got z1 equals 1 plus 2i, then the other root, z2 is equal to 1 minus 2i. So we can form a little quadratic. We're going to say that z squared plus this, or minus the sum, is minus z1 plus z2 of z plus the product z1, z2. And that's going to be equal to z squared minus the sum. And that's going to be adding these two together. These go out and we get just 2. So it's 2z, and then the product plus, we multiply those two together and you get 1 plus, and that's going to give 4. So our little quadratic is z squared minus 2z plus 5. So that means that z cubed minus 4z squared plus 9z minus 10 must be equal to z minus some constant, say a, times this one, z squared minus 2z plus 5. Now simply by substituting a value in here, because this is an identity of, say, z equals 0, we get that z equals 0, we get minus 10, put out, is equal to, that will be equal to minus a, and these go out times 5. So you can see that a must be equal to 2. So therefore the roots are 2, 1 from here plus 2i, and its conjugate 1 minus 2i are the roots. Done.